So, hello everyone, how are you? Again, I welcome you all in this session of class 12th, alternating current. So, it's a long week off because of Diwali, and I have you have enjoyed your Diwali vacation. Now, let's just get back to work. And the alternating current we have already started. We have two lecture ahead in this topic. So, this is the lecture third, and most probably we are going to finish it in upcoming 1 or 2 days. Okay. So do not worry about it. Let's just get started with it. Yeah. So if I talk about the previous sessions, what we have learned about the what is phasor, how do we utilize phasor in alternating current, what is alternating current actually, types of currents, DC and AC. Then we have make a circuit of pure resistor, and then we have seen what is the concept of lag and concept of lead, and also draw the phasor diagram of different circuits. Now today also we are going to draw the phasor diagram for an inductive circuit. So as you can see on your screen, there is an inductive circuit given in this. You can see there is a source of voltage which is AC. This is symbol represent the AC voltage. So here E is equals to E naught sin omega t is the EMF across the inductor having inductance L. Okay. Now a current I is being flown into this circuit due to this source of EMF. Now, what we can do, we can apply the Kirchhoff's loop rule. Kirchhoff loop rule we have seen in the current electricity, and it says that whatever the circuit you are talking about, if it is closed, the net EMF or loss or gain of the voltage or the EMF should be zero. Okay, and it based on the principle of conservation of energy. Okay, so we can say that applied voltage is equals to self-induced EMF, because this is an inductive device. This is an inductor. And in latest chapter that we have covered recently in electromagnetic induction, we have seen that in inductor, there is an induced EMF, self-induced EMF, because of the flow of current. Because as current flow through this circular turns, there is also magnetic field crossing that turns. And since it is a alternating current, the magnitude of the current is changing. If the magnitude of the current is changing, the magnetic field it produces will also be changing in nature. If that is changing, which means the magnetic flux associated to this particular value of current will also change. And change in magnetic flux leads in the induced EMF, and that is known as self-induced EMF, which is in case of inductor is given by LdI by dt. But the applied voltage in this case is E is equals to E naught sin omega t. So according to Kirchhoff law, whatever the voltage you are talking about in this circuit should be zero. So we have this source of EMF and self-induced EMF. Okay. So due to conservation of energy, this applied voltage should be equals to this self-induced EMF. Okay. Now E is equals to L di by dt. This is self-induced EMF. So from here you can calculate the value of current. Di by dt is E by L. Put the value of E, which is E naught sin omega t upon L. Now di, we need to calculate the value of current so that we can see which quantity, either this potential difference, or you can say the applied voltage, is lagging or leading. So for that we need two quantities. First we have as a EMF or applied voltage. And second we have as current. Okay. So E is equals to E by L, E naught sin omega t by L. So here, if you calculate the value of di, it should be E naught by L sine omega t into dt. Okay. So di, if you integrate it, you get the total value of current, which is coming out as E naught omega L minus cos omega t. The integration of sine omega t will be cos minus cos omega t divided by omega. I have told you in the previous sessions. So this omega is multiplied into the inductance. This omega L, it seems like E naught by R, V by R. It seems like resistance to the circuit. So this inductor also provide a resistance to the circuit, which is termed as omega L and called inductive reactance. What is this quantity called? Omega L is called XL, which is nothing but inductive reactance, the resistance provided by the inductive circuit or the inductor itself. So from here, we want to have these two quantity, E and I, in same trigonometric ratio. So here E is in E naught sine omega t. So we want the current to be in sine also. So it would be sine omega t minus pi by 2. Why minus pi by 2? This minus will consume inside. If you take minus common, it will become pi by 2 minus omega t. Sine pi by 2 minus omega t will become cos omega t, and already minus is outside. So ultimately will lead to the minus cos omega t. Clear? So from here you can see I is equals to I naught sine omega t minus pi by. Okay. I hope this is clear to you. Now I naught is nothing but the maximum value of current, which is E naught by XL. Same concept as Ohm's law. Okay. Do not need to worry about it. Now, based on this question, let's just try to solve this based on the concept that we have seen in the previous slide. Let's just try to solve this question. So here in the circuit shown below, the inductance L is connected to an AC source. The current flowing in the circuit is I is equals to I naught sine omega t. The voltage drop across L is. So we know that V is equals to voltage drop in inductive circuit is V is equals to L di by dt. Okay. Now, V is equals to L into d by dt. What is the value of I given to you? I naught sine omega t. The differentiation of sine omega t will become I naught is common. So you can, I naught is constant. So you can take it from L I naught. D by dt of sine omega t will become omega into cos omega t. Okay. So it is coming out as V is equals to I naught into L. I naught into omega L cos omega t. Okay. So as you can see in the answer, I naught into L, omega L into I naught into cos omega t. Option 4 is the correct answer of this question. This is from NEET 2024. Option D is the correct. Okay, look how easy question was. Okay, I hope that you will got this concept. Now we will have a look about the instantaneous power supply to an inductor. Because a current is flowing, an EMF is also generated. So what is the power? Power across an inductor is given by I into V. Whatever the device we have, power is always given as I into V. So here power I की value you will put I is equals to I naught sin omega t minus pi by 2, then E naught sin omega t. Okay, this is the value of V here. Got it? Now, if you just calculate, you can make this sin omega t minus pi by 2 as minus cos omega t from the previous case. We know that this sin omega t minus pi by 2 is nothing but minus cos omega t. So it is coming out as like this. But this is a fluctuating power. We want to know the value of average power over a complete cycle. So average power over a complete cycle would be zero, because I have told you in the previous sessions that the average value of sine theta should be zero over a complete cycle. Okay. So here this sine 2 omega t is nothing but the omega. Clear? So average power across the inductor is zero. Clear? Now यहाँ पे आप देख भी सकते हो. This is a graph. If you draw the phasor diagram of it, let me just introduce phasor diagram. This one. So here we have E naught, which is at omega t angle. E naught का equation क्या था? E का equation is E naught sin omega t. So we have this magnitude, this E naught is the maximum length of this particular vector or this phasor, E phasor or voltage phasor. Omega t is the angle in the anti-clockwise sense, this sense, from the positive axis. Okay, this is it. But we know the expression of current is here is I is equals to I naught sine omega t minus pi by 2, which means it is less than omega t. Okay. So if this angle is 90 degree, this angle is 90 degree, this must be, this total angle is 90 degree. The phase difference between I and E, if you will see, it is omega t. Let's say phi 1. It is omega 2. It is phi 2. So here phi 2 minus phi 1 would be, the phase difference here is, uh, yeah, omega t minus pi by 2 minus omega t. Omega t and omega t will cancel out. So the total phase difference that you are getting in the negative side, which is minus pi by 2. Minus pi by 2 means this vector or this phasor should be drawn from the positive x-axis, but in the opposite sense of omega. Clear? Okay. So that is why we have a phase difference between E and I is 90 degree. And you have to move in anti-clockwise, in the clockwise sense, in the opposite manner. You have measured omega t in this way, you have to measure pi by 2 in the opposite. Clear? And one of the another method is also, this is omega t. Okay, this angle is omega t minus pi by 2, which means omega t you have to cover and then pi by 2 you have to cover. Okay. Clear? So this angle is less than omega t. Omega t में से कुछ घट रहा है ना, so this angle is less than omega t. So that is why if this is the angle perpendicular to it, pi by 2, this angle would be pi by 2 minus, because this angle is omega t and total angle is 90 degrees, so it would be pi by 2 minus omega t, which means here the current lags with voltage with a phase difference of pi by 2, which means जब करंट अपनी मैक्सिमम वैल्यू गेन करेगा उससे पाई बाई टू एंगल पहले ही ई ने अपनी मैक्सिमम वैल्यू गेन कर ली। और इसे ऐसे भी समझ सकते हैं, when E will gain its maximum value or any particular value, current will get that same value after a 9 after 90 degree of phase difference. So you can see here, देखो, E is getting its maximum value at pi by 2, but the current is getting its maximum value at pi. ठीक है, which means pi by 2 later. E ने तो पहले ही अचीव कर लिया, करंट ने बाद में अचीव किया, कितना बाद में, पाई बाई टू एंगल, पाई बाई टू रेडियन बाद में। ठीक है, इसलिए ये वेक्टर ऐसे रोटेट करेगा, ये वेक्टर इसके पीछे पीछे ऐसे रोटेट करेगा विद अ फेज डिफरेंस ऑफ 90 डिग्री। ठीक है, सो एवरेज पावर ओवर अ कंप्लीट साइकिल इन इंडक्टिव सर्किट इज जीरो। ठीक है, तो जितनी भी पावर ये कंज्यूम करता है, सारी की सारी पावर रिटर्न कर देता है बाद में। ठीक है, नाउ एसी अप्लाइड टू अ कैपेसिटर। एसी अप्लाइड टू अ कैपेसिटर, तो यहाँ पे हमने कैपेसिटर लिया है, वी हैव टेकन ए कैपेसिटर ऑफ कैपेसिटेंस सी and a current I is being flown in this circuit, and we have take a alternating current source E is equals to E naught sine omega. So due to this current there will be a charge induced on the plates of this capacitor, which is plus q and minus q, let's say. Okay, so at any instant let the charge is q, let the charge is q, and we know that q is nothing but, here we have taken E as a potential difference or voltage. Generally we expressed voltage in terms of V, so that is why we very much aware about this formula, Q is equals to CV. But in place of V here we have put it E, so Q is equals to CE. E here will become Q by C. E की value is given as E naught sin omega t, so it will become E max sin omega t or E naught, you can take it as E naught also or E max, whatever you like. Okay, EM भी गलत नहीं, EM is also correct. So E naught sin omega t equals to Q by C. This step. After that, Q is equals to C E naught omega t. We know that Q is nothing but amount of charge, but we are interested in finding out the current. And current is nothing but dq by dt. So we have to differentiate this equation number one. When we differentiate it, it will become omega C E naught sin omega t. Sorry, it will become, when we differentiate it, I is dq by dt, it will become cos omega t. Just a spelling error here, cos omega t. Here, if you will see, you have a term omega c, and that is E naught. But according to Ohm's law, V is equals to IR only. V is equals to IR, which means I is equals to V upon R, which means whatever the circuit resistance, it should be in denominator of the potential difference. But here, this quantity is coming in the multiplication of it. It should be dividing it. So that is why we write a term as omega xc, which is nothing but 1 upon omega c. Okay. So to be divide this omega c, we have write it like this. If you are confused in it, let me do it here. E naught upon 1 upon omega c, and it is nothing but when you multiply it, it will go on the third place. It will again gives you omega c E naught. Okay. So 1 upon omega c, we will count it as xc. Okay. Which is nothing but the resistance provided by the capacitor, which is termed as capacitive reactance. ठीक है. So I here will become E naught upon XC cos omega t, I naught sin omega t. Again, we want E and this I in the same trigonometric ratio to analyze in a better way. So it will be is equals to E naught sin omega t. So it should be, it is positive cos omega t. So we can write E I naught sin omega t plus pi by 2. माइनस पाई बाई टू भी लिख सकते हैं, बट इन दैट केस माइनस ओमेगा टी विल रिटर्न. ठीक है. So here you will see, just check this value. Just a second. Huh. So this XC represents the resistance provided by the capacitor in the circuit. Okay. And that is why we have a different name of it, which is capacitive reactance. XC is equals to 1 upon omega C, capacitive reactance. Okay. Now, we have converted the current also in the same form as it is also plus pi by 2. Okay, omega t plus pi by 2, which means in the previous case it is showing that current is omega t minus pi by 2. In this case it is showing that omega current is nothing but omega t plus pi by 2. Okay. In this case we can say that current in a pure capacitive circuit is lead the voltage by pi by 2. Okay. Here current is in lead mode. क्लियर है. तो करंट क्या कर रहा है यहाँ पे, लीड कर रहा है विद एन एंगल ऑफ पाई बाई. क्लियर. विच मीन्स वट एवर द वैल्यू current will achieve at a particular instant of time, the same value will be achieved by this potential difference or the alternating voltage after a pi by 2 radian angle. Okay, clear. Now based on this concept, let's just try to solve this question. So in this question, if you will see, a 10 microfarad capacitor is connected to a 210 volt 50 hertz source. As shown in figure, the peak current in the circuit is nearly. Okay. So capacitance is given you as 10 microfarad. Okay. E is given to you. This 210 volt is the peak value. Okay. Just give me a second. Huh? Just give me a second. I have to check the values of this question. Okay. So as I show you in this question, this 210 volt, in every question these types of data will be mentioned. So you must aware about what is this 210 volt given to you. Until and unless it is not mentioned that it is a peak value, you have to consider this 200 volt or whatever the value is given as the RMS value. So VRMS given is 210 volt. We know that V naught IRMS is nothing but, sorry, VRMS is nothing but V naught by root 2. So here the peak value will become VRMS root 2 times. This means 210 into root 2 volt. Okay. Why we are calculating the peak value, we'll get to. The peak current in this circuit is nearly. We know that for peak current, we must calculate I naught is nothing but V naught upon XC, because here this is a pure capacitive circuit. So applying Ohm's law type of thing, you will see that this is V is equals to I into R. R here is XC, which is capacitive reactance. So only thing you need to calculate here is XC. XC is nothing but 1 upon omega C. Oh, one more thing, this 50 hertz is linear frequency and this omega is the angular frequency. So you have to calculate omega in terms of f. So omega ki value will be 2 pi f into C. 1 upon 2 pi into 50 into, you need to put the values here. When you calculate the value of xc, you need to put it here. V naught you have already calculated. And based on this data, just calculate the value of peak current and you will get to find out the answer one of this. Okay. So look how easy questions is being asked in NEET examination. If you just know the concept. Now, again, we also have to calculate what is instantaneous power in this across a capacitor. So instantaneous power across a capacitor will be P is equals to V into I. Again, you need to put the value of V and I. So it is E naught sine omega t. V naught sine omega t plus pi by 2. देखो, in this case, just a second. Here we have calculated I with a phase difference of plus pi by 2. ठीक है? So we have put the value of current as, देखो यहाँ पे थोड़ा मिस्टेक हो गया, ये V नोड ही आप रख, E नोड ही रख लो दोनों टर्म्स. I नोड हो गई, I नोड. ठीक है. So it will become E naught I naught sine omega t plus pi by 2. Sine omega t plus pi by 2 will become cos omega t. ठीक है. 2 से मल्टीप्लाई 2 से डिवाइड करेंगे तो दिस विल बिकम sin 2 theta is equals to 2 sin theta into cos theta. ओके. यहां से आप देख सकते हो sin theta into cos theta, you can write it as sin 2 theta by, same here we have did sin 2 omega t by, but average, again average value of sin 2 omega t will be 0. So here it is also 0. ठीक है. Clear है. Now the phasor diagrams. So phasor diagram के लिए you need to calculate the peak values. Peak value is E naught. This is the length of this vector and angle is omega t. We know that V is nothing but E naught sin omega t. Omega t is the angle measured from the x-axis, positive x-axis, in the anti-clockwise sense. Then what is the phase difference between them? Plus pi by 2. Okay. What is the phase difference between them? Plus pi by 2. Which means you have to move more 90-degree more to reach the current. So in this case, it is automatically clear that current is leading here and voltage is lagging. Okay. So in this scenario, current leads. Okay. It is omega t plus pi by 2. Omega t we have already covered and only we have to cover is pi by 2. So it is plus pi by 2. So current lead in this circuit with a phase difference of pi by 2. Again, if you will see whatever the value E naught or this potential difference will achieve, current will have achieved that value pi by 2 angle before. देखो यहाँ पे. If you will see this is E. So E has its value 0 at pi, but current has its value 0 at pi by 2 already. So there is a phase difference of pi by 2. Okay. We can say that current is leading in this situation. Now what we have did, we have combined two devices and then we analyzes it based on the alternating situations, alternating current. Okay. So if we combined two circuit one together, like we have taken a resistance and inductance, then we will take resistance and capacitance. Then how this circuit behave in the presence of alternating current or alternating source of voltage or energy? So this is the first circuit that we are going to analyze is AC through LR circuit. In this circuit, we have assumed that there is resistance in this circuit, pure resistor and pure inductive. That is why we have analyzed pure inductive, pure capacitive and pure resistive circuit separately. So that now you have an idea about what it is. What is the potential difference across a resistor? What is the lag and lead concept? Okay. सो करंट इज सेम इन बोथ ड्यू टू सीरीज कनेक्शन है तो करंट तो सेम होगा ही होगा. करंट हियर इज आई. वोल्टेज ड्रॉप अक्रॉस रेसिस्टर इज वीआर एंड वोल्टेज ड्रॉप अक्रॉस अ इंडक्टर इज वीएल. ठीक है. We have seen from a pure inductive circuit that voltage lead, ठीक है, with an angle of pi by 2, or you can say the current lag in inductive circuit. You have to pick one. Either you are talking about the current only or you will talk about the potential difference or EMF. So here we will take EMF because current and EMF both are in phase with the resistive circuit. Resistive circuit में कोई लॉस होता ही नहीं. ठीक है. हेलो मामोनी देवी, हाउ आर यू? ठीक है. सो रेसिस्टिव सर्किट में कोई लॉस होता ही नहीं है. लॉस नहीं होता इसका मतलब ये है कि ना तो वोल्टेज लीड करता है ना करंट लीड करता है, दोनों सेम सेम चलते हैं, साथ साथ चलते हैं. ठीक है. सो एदर यू विल टॉक अबाउट वोल्टेज और टॉक अबाउट करंट, इट विल बी सेम in the resistive circuit. But if you are talking about the current in inductive circuit, it is lagging within a phase difference of pi by 2. We have seen in the previous slide. And if you talk about voltage, it is leading the current with an angle of pi by 2. ठीक है. देखो, current in same both due to series. So I is equals to I naught sin omega t. We have considered that. ठीक है. Now voltage drop across inductor is VL is equals to L di by dt is equals to L I naught omega cos omega t. This is the potential difference across the inductor. क्योंकि उसमें self induced EMF है. So it is given by L di by dt. ठीक है. So this become L I naught omega t. It is seems like I naught into R, and in place of resistance omega L is placed. Omega L is nothing but the inductive reactance of the circuit. So VL here will become I naught XL cos omega t. This is equation number 1. Now voltage drop across resistor is same. VR is equals to VM sin omega t, V naught sin omega t. ठीक है. So it is given by I into R. I की value I naught sin omega t into R. So this I naught R is nothing but the maximum value of voltage across resistor. Similarly, I naught XL is the maximum value of voltage across inductor. But due to the conservation of energy, we can say that whatever the amount of voltage we have provided, these two voltage difference lies within the same. Okay? Which means these two value, if you add these two value, they will not exceed the value of applied voltage. Clear? So we can say that VR plus VL is equals to capital V. Now put the value of VR and VL. Now this type of equation you have solved in wave in 11th class. ठीक है. A sin omega t, A sin omega t, A sin theta plus B cos theta type of equation. So for that, what you will do? You will take these coefficient. ठीक है. Clear है? And assume them as A sin phi, Z sin phi, and B को you will assume at Z cos phi. So that you will make a formula type of thing, which is sin A plus B, sin A plus B, or sin A minus B type of thing. So here I node is common, so we can take it common. Only R and XL is here. So R को we can represent as Z cos phi and XL को we will represent as Z sin phi. So what happens here is when you put this value of R into this equation, it will become I node Z cos phi sin omega t plus I node, you will put the value of XL, I node Z sin phi cos omega t. It is becoming a formula of sin omega t plus phi. Because if you open up this, it will become sin omega t cos phi plus cos omega t sin phi. And this is same. Z is common in both of them. So finally, the applied voltage is coming out as I node into Z sin omega t plus phi. Now, what is this phi? Phi here is the phase difference. What is phi here? Phi is the phase difference. Okay. And for this, if I draw the phasor diagram, this is current for a large circuit with an omega t angle. I is equals to I naught sin omega t. इसमें तो कोई प्रॉब्लम नहीं. I नोड का लेंथ होगा और ओमेगा टी एंगल होगा फ्रॉम पॉजिटिव एक्स एक्सिस. ठीक है, क्लियर है, इन एंटी क्लॉकवाइज सेंस. लेकिन जो रिजल्टेंट वोल्टेज आई है दैट इज जेड साइन ओमेगा टी प्लस फाइव. तो बस प्लस फाइव को एक्सटेंड कर दो, मींस आई से प्लस फाइव एंगल. तो ये एंगल कितना होगा, ये एंगल आई से प्लस फाइव चलेगी, तो टोटल एंगल विल बिकम ओमेगा टी प्लस फाइव. क्लियर. As you can see that voltage is leading in this situation, and it has to be because it is a pure inductive sorry, it is an inductive circuit. Okay, what is phasor? I'll tell you. Just give me a moment. What is a phasor? I'll give you a quick review about the phasors. So here, so phasor is nothing but, देखो अगर कोई भी क्वांटिटी है which is alternating in nature, जैसे हम यहाँ पे alternating current और alternating voltage की बात कर रहे हैं. So these are the alternating quantities which change its magnitude. So to represent these types of quantity, we introduce the concept of phasor. Phasor is nothing but a rotating vector. ठीक है, जिसकी लेंथ क्या होगी, maximum value of that particular alternating quantity. Let's say for example, V is equals to V naught sin omega t is the alternating voltage. So if I want to represent V as a vector or a phasor, first of all, so the length of that phasor would be what? The maximum value of this, और maximum value कितनी होगी, V naught. एंड एंगल, क्योंकि वेक्टर को ड्रॉ करने के लिए वी नीड टू क्वांटिटीज, मैग्नीट्यूड और एंगल. तो एंगल शुड बी दिस क्वांटिटी. ओके, ओमेगा टी. ठीक है, फ्रॉम पॉजिटिव एक्स एक्सिस. ठीक है, तो दिस इज फेज. लेंथ ऑफ फेजर आई हैव टोल्ड यू ऑलरेडी. क्लियर है. So at any instant, the angle made by phasor with positive x-axis represent the phase of oscillating quantity. Which means what is phase? Phase का मतलब होता है कि what is the status of that quantity. अभी उस quantity का status क्या है, उसकी value क्या है. Status means value. Suppose omega t will become zero. So this v will become zero because v not sin omega zero. Sin zero is zero. So can it represents? It is representing the what? The status of the alternating quantity. क्लियर है. सो फेज का मतलब होता है कि स्टेटस को कैसे रिप्रेजेंट करता है. ठीक है, किसी भी क्वांटिटी का, ऑल्टरनेटिंग क्वांटिटी का स्टेटस जो रिप्रेजेंट करता है दैट इज अ फेज. और उस फेज प्लस उसका मैक्सिमम वैल्यू उस पर्टिकुलर क्वांटिटी को कंबाइन कर देंगे तो वी हैव अ फेजर. ठीक है, तो फेजर इज अ रोटेटिंग वेक्टर, यू कैन से, which rotates its anti-clockwise sense. Anti-clockwise sense में तभी सारे एंगल किसमें, एंटी-क्लॉकवाइज सेंस में मेजर. ठीक है, अब देखो, अगर मैंने ये कोई फेजर बनाया, ये मैंने एक फेजर बनाया V, और ये इस वक्त ओमेगा टी प्लस फाइव एंगल पे, तो इस फेजर की वाई एक्सिस पे जो प्रोजेक्शन होगी is the magnitude of this alternating quantity at this particular phase or this particular instant. ठीक है, तो किसी भी इंस्टेंट पे अगर किसी फेजर का मैग्नीट्यूड निकालना है, किसी भी पर्टिकुलर क्वांटिटी का जो कि ऑल्टरनेटिंग है इन नेचर, मैग्नीट्यूड आपको निकालना है, तो यू जस्ट हैव टू कैलकुलेट द प्रोजेक्शन ऑफ वाई एक्सिस। ठीक है, इसे ऐसे भी रिप्रेजेंट करते हैं, देखो जैसे आई को आई नॉट साइन ओमेगा टी, तो ओमेगा टी से रिप्रेजेंट किया। अब मान लिया आई को दोबारा रिप्रेजेंट करना है ओमेगा टी प्लस फाइव, तो ये फाइव एक्सटेंड हो जाएगा। अब मेरे पास जो नई क्वांटिटी आएगी, लेट मी ड्रॉ इट हियर, दिस इज आई एट ओमेगा टी, और ये ओमेगा टी प्लस फाइव है। ठीक है, क्लियर है। अब देखो दोनों का मैग्नीट्यूड चेंज हो रहा है ना, प्रोजेक्शन ऑन वाई एक्सिस इज चेंजिंग। क्लियर, फेज डिफरेंस फाइव फाइनल माइनस फाइव इनिशियल से देते हैं। देखो ये फाइव फाइनल था ओमेगा टी प्लस फाइव, और फाइव इनिशियल था ओमेगा टी, तो फेज डिफरेंस कितना है फाइव का, तो देख भी सकते हो दोनों क्वांटिटी के बीच में कितना डिफरेंस है, फाइव का ही तो। फेजर इज ओनली एप्लीकेबल फॉर ऑल्टरनेटिव करंट, नॉट ऑल्टरनेटिंग करंट नहीं, फेजर इज एप्लीकेबल टू दोज क्वांटिटी विच is periodic in nature and change its magnitude over a period of time and then repeat its value like trigonometric functions. ठीक है, so you can represent the trigonometric function as a phasor. clear, for example देखो ऐसे, ये देखो ये साइनोसोडल वेव फॉर्म हो रही है, और यहाँ पे एक वेक्टर है जो रोटेट कर रहा है एंटी क्लॉकवाइज सेंस। दोनों के दोनों सेम ही क्वांटिटी को रिप्रेजेंट कर रहे हैं, बट रिप्रेजेंटेशन का वे डिफरेंट है। तो इसी का ही एक पर्टिकुलर स्नैप आप यहाँ देख सकते हो। कोई भी क्वांटिटी अगर ऑल्टरनेटिंग है इन नेचर, ऑल्टरनेटिंग मींस पीरियोडिक है, पीरियोडिक के साथ साथ विच कैन, व्हाट इज अ पीरियोडिक क्वांटिटी विच रिपीट इट्स वैल्यू आफ्टर अ सर्टेन पीरियड ऑफ टाइम। तो साइन थीटा कोस थीटा क्या करते हैं, अपनी वैल्यू को रिपीट करते हैं सर्टेन पीरियड ऑफ टाइम। ठीक है, दैट इज व्हाई दे आर ऑल्टरनेटिंग क्वांटिटी। देखो यहाँ पे मुझे चाहिए, ये मेरा फेजर यहाँ पे है इस पर्टिकुलर, तो देखो अगर मैं वाई एक्सिस पे इसकी प्रोजेक्शन लूं, तो ये इसका मैग्नीट्यूड है। सेम अगर आप यहाँ पे देखो तो साइनोसॉइडल में ये वैल्यू यहाँ पे है, सेम लाइन में कर दिया, ये वैल्यू है। पीक वैल्यू तो नहीं है, पीक वैल्यू कहाँ पे होगी, जब ये वेक्टर रोटेट करके पाई बाई टू पे आ जाएगा, तो यहाँ पे ये पीक वैल्यू बना लेगा। यहाँ आप देख सकते हो, यहाँ पे जब भी ये 90 डिग्री पे हिट करता है फेजर, तो ये वाली क्वांटिटी जो है देखो मैक्सिमम पे जाती है। ठीक है, आई होप दैट यू गॉट दिस कॉन्सेप्ट। किसी तरह का कोई डाउट है इसमें? गुड, और क्लासेस थोड़ा टाइम से ज्वाइन किया करो। ठीक है, तो यहाँ पे हमने देखा था एलआर सर्किट से कि मेरा जो करंट है वो, वोल्टेज जो है वो फाइव एंगल से लीड कर रहा था। ठीक है, उसका फेजर मैंने अब बनाया, देखो आई इज इक्वल टू आई नॉट साइन ओमेगा टी था, सीधी क्वांटिटी थी। ओमेगा टी एंगल हो गया, आई नॉट इसके लेंथ होगी, आई इसकी एक पर्टिकुलर इंस्टेंट पे वैल्यू है, इसी पर्टिकुलर इंस्टेंट पे। ठीक है, विच इज गिवन बाई आई नॉट साइन ओमेगा, वी जेड साइन ओमेगा टी प्लस फाइव था, तो प्लस फाइव से ये एक्सीड कर रहा है, तो ये। अब यहाँ पे एक इंपॉर्टेंट टर्म आती है रेसिस्टेंस को लेकर के, व्हाट इज द रेसिस्टेंस ऑफ दिस सर्किट, एलआर सर्किट। सो वो गिवन बाय, दैट इज गिवन बाय दिस इम्पिडेंस ट्रायंगल। सो वी कैन से दैट दिस इज आर एंड दिस इज एक्सएल। देखो ये कैसे हुआ, तो just try to understand. In the previous slide we have taken an assumption that z is equals to, sorry, r is equals to z cos phi and xl is equals to z sin phi, ये assumption हमने लिया। अब अगर आप इन्हें इक्वेशन बनाओ और डिवाइड कर दो दोनों इक्वेशन को, इक्वेशन टू बाई इक्वेशन वन, so you will get a 10 phi on the RHS and it will become xl upon r. ठीक है, so if there is a right angle triangle, so this, if this angle is phi, let's see, So tan phi is xl upon r. What will be this value become? This is the hypotenuse of this right angle triangle, which is nothing but r square plus xl square. And this is the actual resistance which is coming out as Z and which is termed as impedance of the circuit. ठीक है, अब देखो ये स्क्वायर की वैल्यू आप ऐसे भी निकाल सकते हो, cos स्क्वायर फाई plus sin square phi is equals to 1. You put the value of cos phi and sin phi, then you will find out that it will become r square by z square plus xl square by z square is equals to 1. So r square plus xl square is equals to z square. ठीक है, तो यहां से भी ये बात वैलिड क्लियर है. So that is why we are forming the impedance triangle so that we would know what is the value of Z. Z is the actual resistance feel or faced by the alternating current when it is flowing through a LR circuit. LR circuit. तो LR circuit का total resistance कितना है? Which is Z. ठीक है, और Z को हम क्या बोलते हैं? Impedance बोलते हैं. Impedance of the circuit. So impedance of the LR circuit is also V naught by I. And here V EMF V lead current by phi. ठीक है, पहले चल रहा है. देखो ये क्वेश्चन है इसी पे ही बेस्ड. An AC source is connected in a given circuit. The value of phi will be. ठीक है, तो इस क्वेश्चन का आप स्क्रीनशॉट ले लो और इसे हम नेक्स्ट क्लास में डिस्कस कर लेंगे बिकॉज टाइम इज बीइंग ओवर. ऑल्दो यू हैव एन आइडिया, यहाँ पे L की वैल्यू आपको गिवन है 1/पाई, R की वैल्यू भी आपको गिवन है, V की पूरी इक्वेशन आपको गिवन है, फाई भी आपको गिवन नहीं है फाई. ठीक है, 100 पाई विच मीन्स ओमेगा की वैल्यू आपको गिवन है, ओमेगा टी के प्लेस पे लिखा हुआ है 100 पाई इंटू टी. तो हमें यहाँ पे फाई की वैल्यू निकालनी है. दैट वुड बी आई थिंक वेरी इजी फॉर यू. व्हाट यू कैन डू, tan फाई की वैल्यू आप निकाल सकते हो विच इज r बाई z. सॉरी, tan फाई इज xl अपॉन r. xl क्या होता है? xl इज ओमेगा इंटू एल. ओमेगा की वैल्यू आपको पहले ही पता है, इट इज 100 पाई. एल की वैल्यू आपको पता ही है 1/पाई गिवन इन द क्वेश्चन, सो इट विल बी कमिंग आउट 100 ओम. एक्सएल और एक्सी की यूनिट ओम ही होती है, रेसिस्टेंस ही होता है. सो tan फाई हियर इज, बताओ, एक्सएल की वैल्यू है 100 ओम, आर की वैल्यू इज 100 ओम, सो फाई विल बिकम 45. करेक्ट, tan फाई इज 1. So which value of phi we should put in 10 so that it will make 1? So 45 degrees is the angle. So D is 45. Okay. I hope this information adds up in your brain and makes the valuable of it. So if any kind of doubt you have right now, you can ask right away. Okay. I have launched a poll. Please do answer in that poll so that I can make your attendance. I can mark your attendance. Apart from that, if you have any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive in the question. The only request to you is to join, to be on time. Okay. Thank you.